everyone. Let's continue with chapter 14. We're going to look at um, the symmetry properties of the circular functions and also the exact values of those ratios. So the ratios we looked at were sine, cos, and tangent. We looked at how the ratios fit in any right angled triangle and bring that back to the unit circle. So here is the unit circle that will be split into 4 quadrants. Quadrant 1 will be the angles from 0 to 90 degrees, quadrant 2 from 90 to 180, quadrant 3 from 180 to 270, and quadrant 4 is from 270 to 360. Quadrant 4 is also a special one as it has a symmetry of from the x-axis, and it will link back to what we call negative angles. Now, depending on what quadrant you are in, we're going to use symmetries that will simplify those ratios sine, cos, and tangent back to the first quadrant, where we're going to look in the next exercise the exact values for specific angles. Also, with the angle notation, I mentioned that in the degree unit, but I'm going to transition a little bit more into radiant, as in calculus radiant is the main unit that we use. In real life it's going to be degrees. In nautical notation or on the sea they will use gradient. Alright, pretty complicated with the symmetries. Okay. So there's a lot of formula that you have up there, and I'm going to simplify that in a minute. The first thing we're going to look at is the symmetry of the actual points. So point P in quadrant 1 is, we draw that right angle, has the coordinates cos theta, sine theta, and we're going to bring that back to the coordinates A, B. If we do a symmetry from the y-axis, that point has the coordinates. What we do is we get the opposite of A. That point has coordinates, it's not annotated here, so it's negative A, B. So all we did is with the x coordinate A, we put a negative. Okay. Quadrant 3, it would be negative A, negative B, and with the last one it's a symmetry from the x-axis, so we do a negative B, so it's going to be A, negative B. And then from the A and B, as A represents cos of theta and B represents sine of theta, we can substitute that back. So for example, with that point, graphically we can see they have the same y coordinates. Now the angle in that second quadrant is not theta like we have here, it's actually pi minus theta. So that's the minus theta here. So we start from this point, from the x-axis, we go all the way, we add pi, which is 180 degrees, and we minus theta, so we get that angle. So as the y coordinates is the same, what it means is sine of pi of theta minus theta, which is B, is also equals to sine of theta from the first quadrant. So every time we write a relationship for sine cos from this quadrant, we'll bring it back to the first quadrant. And we're going to do the same with quadrant 3 and quadrant 4. Okay? To get the tangent relationship, we just divide sine by cos. It's a ratio. Alright. To summarize those three relationships of sine, cos, tangent from quadrant 2, 3, and 4, what we use is an acronym. It's ASTC. That whatever works for you. What we use here is all students to Craigieburn. What it stands for is A is for all, S is for sine, so S is for sine, T is for tangent, and C is for cos. So what I underline, for example, for S for sine, sine is equal to sine of theta. For cos and tangent, it will have a negative. Quadrant 3, tangent is underlined, so tangent is equal to tangent of theta from the first quadrant. For sine and cos, it will be negative. And guess what for the last one? C for cos, cos is equal to cos of theta from the first quadrant. And for the others, sine and tangent, you will have a negative. So that's what we summarize here. Let me remove this, give me a sec. So in your notes, you will have a summary of that. ASTC, all students to Craigieburn. And we're gonna use that to simplify some of the calculations. So we start, okay, before we do any examples, with quadrant 4, which is this one, only cos is positive, but quadrant 4 is also because 2 pi is also a full period. We can minus 2 pi to get the negative relationships, which is over here. So cos is the same, sine is the opposite, and tangent will be the opposite. So every time you have a negative angle, think about simplifying. Alright, with the examples, it gives you sine of x. So sine of x is 0.6. That's the value in the first quadrant. So x is your angle in your first quadrant. Listed are the properties below. So when you look at your angle for all those questions, you need to determine in what quadrant you're in. So pi minus x is you are in the second quadrant. What I like to do, is I'm gonna annotate. I forgot to mention that. That's kind of handy. So here is your angle in the first quadrant, so theta. Second quadrant is pi minus theta. Third quadrant is pi plus theta. And in the fourth quadrant, it's either 2 pi minus theta or just a negative angle. Okay, so it could also be a 2 pi in here, or a factor of 2 pi, a multiple of 2 pi. And what you do is you bring it back to the first quadrant. So here is from the second quadrant is also equal to sine of x, because the second quadrant sine is positive, and that equals to 0.6. Sine of pi plus x. You are in a third quadrant. Only tangent is positive, therefore it's negative sine of x, and then you substitute. Fourth quadrant, only cos is positive, so sine will give you negative sine of x, and you substitute with the value. Sine of negative x, similar to the previous one, or you can use the negative angle property with the negative sine of x, and I'll give you negative 0.6. Another example, probably one of the last one using degrees. It's the same idea, just bring it back. Good habit to convert back to radian. So pi to pi, your negative angle property. Think about in what quadrant you're in. So that's Q2, Q3, Q4, and Q4. And you use the property. So it's either basically bringing it back to the first quadrant. You need to know when it remains positive or when it's negative. So here you have the negative here, a positive and a positive, and you substitute with the value given at the start of the question. Alright, so that's what we have for 14E. So it's about the symmetries. Moving on to 14F, we're going to look at exact values of sine, cos, and tangent for specific exact values. The first exact values we're going to look at is 0 and 90 degrees. 0 in radian is 0. 90 degrees in radian is pi on 2. Alright. So for 0 and 90 degrees, you're going to be, for 0 degrees, you're going to be down here where the coordinates are 1 and 0. Therefore, cos of 0 is 1, sine of 0 is 0. So that's your y coordinate, that's your x coordinate. And for pi on 2 or 90 degrees, it's cos of pi on 2 is 0 and cos of pi on 2 is 1. To find a tangent, you do a ratio. So sine over cos is 0, so tangent of 0 is 0. Tangent of pi on 2, as it is 1 divided by 0, it's undefined, so we just write undefined or infinity. Okay, now to find the exact value of 30 and 60 degrees, which is pi on 6 and pi on 3 respectively, I'm going to skip the little C symbol next to it, which to indicate that you're in radian units. It's when you have a factor of pi, it's implied, or a factor or multiple of pi, it's implied that you are in radian unit. If you write a decimal value, you will annotate a subscript C to specify the radian unit. To construct that, to determine the exact value, part of the proofing is you build a equilateral, hang on, I can't get this, an equilateral triangle of length 2, so it's 2, 2, and 2. As the triangle is equilateral, you get 60 degrees all around. If I do draw a vertical line to create a right angle triangle, what we end up is having an angle here of 30 degrees, because as it is 90, 60 plus 30 is 90, and the base of that right angle triangle is going to be equal to 1. To figure out the remaining side, you will use your Pythagoras, and after you do that, you'll be able to figure out the sine, cos, tangent of 60 degrees using your trigonometric ratio in a right angle triangle, and you can do the same for 30 degrees. We summarize that as those values that you will need to know. Okay, let's go back to the triangle ADC. So for example, I just want to show you part of the proofing. So for example, let's do sine of pi on 6. So pi on 6 is 30 degrees. Okay, 30 degrees is over here. To do sine of that, you need to turn your right angle triangle to the sine. It's going to be your opposite over your hypotenuse. Okay, because your opposite is 1 and your hypotenuse is 2, we get a sine of pi on 6, which is your opposite over your hypotenuse, and that's how you get 1 over 2. And you will do the same for cos tangent for that angle as well as that 60 degrees. Okay, now with a little bit of practice you will remember those values, and I'll show you how in the last slide. For pi on 4, you need to create an isosceles triangle of sides 1 and 1. The hypotenuse is square root on 2 using Pythagoras, and you have 45 degrees here, therefore you have 45 degrees there because it's 90 degrees here. And we get sine of cos and cos to be 1 on root 2. If we rationalize the root, it's also equivalent to root 2 on 2. So both values are acceptable. And when you do the ratio, tangent is 1 or 1 on 1. We summarize that as a table. The angles are listed from the lowest to the highest. So 0, 30 degrees, 45, 60, 90. And then you have the first two columns, sine and cos. Tangent is the ratio. Now with sine, the values are going all the way up to 1. They'll take specific values 1 over 2, 1 over root 2, root 3 on 2. Cos will take the same values but going backwards or downwards. So it go, if there's a pattern, if you see the values are increasing, so I'm going to do an arrow here. For cos, it's going backwards. Okay. Also, let's focus on sine. Those values, if I rewrite all of them as a fraction over 2, you'll notice the numerator is actually 0, 1, 2, 3, 4. And as you do square root, they do square root of 0, square root of 1, and square root of 4 do simplify. So you get also the same answer. For cos, it's backwards. And for tangent, you just do a division of sine and cos. Alright, now how to evaluate those values? You're going to need 14e. You're going to use the symmetries. You bring those angles values, they're not in the first quadrant, so you need to identify in what quadrant you're in. With the first one, you are in quadrant 2, so you're going to re-express that in terms of pi. So it's going to be pi plus pi on 4. Another way I'd like to break it down before you get to that is you write it as a fraction over 4, and because 4 divided by 4 is 1. You need to have a 4. You isolate a 4 pi plus 1 pi. And then you separate the fraction to get two fractions. The first one is pi, and then you use a symmetry. In the second quadrant, only sign is positive, so you write negative cos, and cos of pi on 4 from the previous slide, it's root 2 on 2, or 1 over root 2, and you have a negative. With this one, you are in the fourth quadrant. Because you're in the fourth quadrant, 2 pi is equivalent to 2/12 pi. So how do you get 11? You do 12 pi minus pi over 6. You separate the fraction into 2. The left fraction become 2 pi, and you're left with negative pi on 6. Using the negative angles, or quadrant 4, you get negative sine of pi on 6, and sine of pi on 6 is 1 over 2, so you get negative 1 over 2. So there's a lot of things here you need to work out. So when you do the questions or the work example, have on the side your exact values, as well as the symmetry table of the ratios from the fourth quadrants. And that's it for today's video, and I'll see you next time.